Okay, my dear student. Now this is the continuation of the previous lesson I have delivered. The same chapter, chapter number 11, and we'll talk about pushes and pulls, mean we'll talk about the force. Now I will move to the next topic, that is about weight. You heard this word a lot of time in your daily life, and you are using this word for a lot of reasons. First of all, you should know what is a weight. There are different definitions are available. You can choose any one of them, or you can create your own definition if it's giving the same meaning. For example, what is a weight? Weight is the force of gravity due to the pull of Earth. You know that Earth has its own gravitational field, and it is pulling everything towards its center. So we can say that weight is a force. It can be defined another way. Weight is the force by which Earth is pulling everything toward its center. So you can write any one of definition from these two, so that will be fine. Now we'll talk about the unit for weight. Mean like mass is measured in kilograms, temperature is measured in degrees Celsius or Kelvin. So in the same way, the unit for weight is Newton and is represented by the letter N, if you can see here. Okay, now how to find the weight of an object if the mass is given? Quite interesting, very easy. You have the formula for that. What is the formula? Weight equal to mass times gravity. Now we are going to solve a question, so it will help you to understand better how you can use this formula. For example, they have given mass of an object is 2 kg. Find its weight. Now we will use the same formula. Weight equal to mass times gravitational field strength. When you are talking about this G, it is the gravitational field strength. Earth has its own gravitational field strength. If you talk about moon, it has its own gravitational field strength, which is different. So on Earth, the standard value is taken 10, which is here, and in moons it's taken 1.6. so it depends on the place where you are going to measure the weight of the object. Now if you talk about here, the mass of the object is 2 kg. For example, here you will use this one in here, and after that the G equal to 10. If you multiply them, you will get the answer 20, and as I told you, the unit for weight is Newton here. Again, if you know the mass of the object, for example 2 kg, you multiply the value of G, which is on Earth we are taking 10. Some place you will find 9.8, that's also fine, and if you can take 10, it's also fine. So if you will take 10, it will equal to 20. So if any object, if mass is given, you can find its weight. For example, here if the mass is 2 kg, it means its weight will be 20 Newton. I hope it will be quite clear now. Now move to the next thing. Here is quite interesting. If you have the same object, it will show you different weight on different places. Let's talk about here. For example, if you see this object, its mass is 2 kg, and here they have written the values. On Earth its weight is 19.6 Newton. The same object of this 2 kg, if you will take it to the moon, it will give you 3.3 Newton. And if you will take this object in space far away, deep space means far away, so at that time weight becomes 0. Why? For example, if you talk about the first diagram, for example 2 kg, and here on Earth, the value of G, if you remember, we just discussed here this value of G here, that is 10 on Earth, but on moon it is different. On Earth, as I told you, you can take its 9.8. You can take also 9.8. For example, here if I will write it here, you can see if I will multiply 2 multiply by 9.8 instead of 10, so it will give you 19.6. This value they used here. So it is just like the values you are going to use. Sometime you can use 10, sometime you can use 9.8. But the same object, if you will take to the moon, mass will remain same, but due to the gravity of the moon, that is 1 point something, so it will change its weight. Now the same object on the earth, it has weight 19.6 Newton. When it will go to the moon, its weight become 3.3 Newton. But if you see, the mass will remain same on earth and the moon, 2 kg, 2 kg. Now if you will take the same object to the deep space, you will not feel any weight, because in the deep space, there is no gravity. If there is no gravity, it means there is no weight, but still the mass will remain 2 kg. For example, if I multiply 2 by 0, why 0? Because there is no gravity at all. In place of g I put 0. If I will multiply them, what the answer I will get? 0 Newton. So it means that in a space the object become weightless, but we cannot say it will become massless. Mass remains same wherever you will take the object. Try to understand this difference. The mass will remain same wherever you will take the object, but the weight will be changed depending on the value of g or depending on the gravity. Now see another example here. Now she is saying my weight on earth is around 560 Newton. My weight on the moon is around 90 Newton. But she is saying my mass is always same, 56 kg. Got it? So this thing I want to make you understand. Mass will remain same, because what is a mass? It is the amount of matter. It will not change. But weight depends on gravity. If the gravity will change, automatically weight will change. Understand? Okay. Now we will see the difference between the mass and weight. From here it will make your concept more clear, that how you can differentiate between mass and weight. For example, if you talk about their definition, so mass is the quantity of matter in a body regardless of its volume or of any force acting on it. So it means that mass is purely amount of matter in an object. But if you talk about the other side, mean weight, they're saying weight is the measurement of gravitational force acting on an object. So this is the difference between their definitions. Now if you talk about the gravity, effect of gravity, so we can say that mass is always constant at any place and any time. It will not change. If you will measure the mass of the object on earth, on the moon, on space, it always remains same. But on other side, mean the right hand side, the weight of an object depends on the gravity at that place. If the gravity is changing, automatically the weight is changing. Now if you talk about their units, so we can say that here the unit of the mass is gram, kilogram, milligram. SI unit is kilogram, which is here, but sometimes the mass will be given in grams also, and sometimes it can be given in milligrams also. But if you talk about the weight of the unit of the weight, that will be Newton. So this is the main difference between these two, mass and weight. I hope you understood all this video about today. So inshallah we will continue for the next video. Thank you very much.